नमस्कार स्टूडेंट्स। आज हम आप लोगों के लिए मशीन लर्निंग में एक बहुत ही इम्पोर्टेंट टॉपिक है जेनेटिक एल्गोरिथम, उसके बारे में लेक्चर लेके आया हूँ। उससे पहले भी मैंने मशीन लर्निंग के बहुत सारे वीडियो बनाए, आप लोगों ने देखे होंगे। नहीं देखें तो आप मेरी प्लेलिस्ट में जाके आप 1 बाय 1 देख लीजिए। दूसरी चीज़, वीडियो शुरू करने से पहले मैं आप लोगों से रिक्वेस्ट कर रहा हूँ कि मेरे यूट्यूब चैनल को आप सब्सक्राइब ज़रूर कीजिए, लाइक कीजिए, कमेंट कीजिए और शेयर कीजिए। सो टुडे वी विल डिस्कस ऑफ द जेनेटिक एल्गोरिथम कि जेनेटिक एल्गोरिथम क्या होता है, क्यों इसके यूज में लिया जाता है और किस तरीके से नेचुरल सिलेक्शन प्रोसेस के थ्रू इसको यूटिलाइज किया जाता है, और जेनेटिक एल्गोरिथम के कौन कौन से ऑपरेशंस होते हैं, उन सारी चीज़ों के बारे में हम देखेंगे। सो जेनेटिक एल्गोरिथम को हम नेचुरल सिलेक्शन जेनेटिक्स भी बोल सकते हैं, जिसके अंदर हम एक हिस्टोरिकल डेटा को डायरेक्ट सर्च के लिए एक बेटर परफॉर्मेंस के रूप में एक सॉल्यूशन हम फाइंड आउट करना चाहते हैं, इसलिए हम इनको यूटिलाइज करते हैं। सो जेनेटिक एल्गोरिथम आर एडेप्टिव ह्यूरिस्टिक सर्च एल्गोरिथम्स that belong to the larger part of evolutionary algorithms. Genetic algorithms are based on ideas of natural selection and genetics. These are intelligent explanation of random search provided with the historical data to direct the search into the region of better performance in solution space. They are commonly used to generate high quality solution for optimization problems and search problems. Then genetic algorithm simulate the process of natural selections, which means those the special who can adapt to change in their the environment are able to survive and reproduce and go to next generations. In simple words, they simulate the survival of the fastest or fittest among the individual of the consecutive generation for solving a problem. Each generation consists of the population of individuals, and each individual represents a point in search space and possible solution. Each individual is represented as a string of data, and a fitness score is given to each individual, which shows the ability of an individual to complete. The individual having the optimal fitness score or near optimal are shown. The genetic algorithm maintain the population of n individuals, जिसको हम बोल सकते हैं क्रोमोसोम और सॉल्यूशंस, along with their the fitness score. The individual having the better fitness score are given more chance to reproduce than other. The individuals with the better fitness score are selected who made and produce the better offspring by combining the chromosome of a parents. The population size is static, so the room has to be created for new arrival. So some individuals die and get replaced by new arrival, eventually creating new generation. When all the mating opportunity of the old population is exhausted, it is hoped that over successive generations better solution will arrive while least fit dies. Each new generation has on average more better genes than the individual solution of the previous generation, though each new generations have better practical solutions than the previous generations once the offspring produced having no significant difference from the offspring produced by previous population. The population is coveraged. The algorithm is said to be coveraged to a set of solutions for the problems. Then operators. Operators of genetic algorithms. Once the initial generation is created, the algorithm evolves the generation using the following operations. First operations, selection operation operator. The idea is to give the performance to the individual with good fitness score and allow them to pass their genes to successive generations. दूसरी बात हम करेंगे तो इसके अंदर क्या होता है, जब हम पर्टिकुलर किसी भी सक्सेसिव जनरेशन की बात करें तो इसके अंदर एक होता है बिफोर म्यूटेशन, एक होता है आफ्टर म्यूटेशन। बिफोर म्यूटेशन क्या होता है, जितने भी पासेस होते हैं एफ जी एच बी सी डी ये ब्लैक होते हैं। आफ्टर म्यूटेशन क्या होता है, इसके अंदर कुछ कलरिंग चेंज हो जाता है। इस तरीके से हम इसकी बात करते हैं। द होल एल्गोरिथम कैन बी समराइज्ड एज फर्स्ट वन इज द रेंडमली इनिशियलाइज पॉपुलेशन पी, सेकंड डिटरमाइन फिटनेस ऑफ पॉपुलेशंस, थर्ड until coverage repeat, then one select parents from the population, crossover and generate new populations, perform mutation on new populations, calculate fitness for new populations. Then after example problem and solution using the genetic algorithms. Give a target string. The goal is to produce the target string starting from a random string of the same length. In the following implementation, following analogies are made. Characters A to Z, A to small z, 0 to 9 and other special symbols are considered as genes. A string generated by these characters are considered as chromosome solution individuals. Next, fitness score. Fitness score is the number of characters which differ from the character in target string at the particular index. So, individual having lower fitness value is given more performance. Then, we can create genetic reproduction. Genetic reproduction means reproduction is controlled by the mutation and crossover operations. Crossover defines the procedure for generating a child from two parents. Before the actual crossover is performed, the parent need to be selected. Several selection schemes are possible. Number 1, the best individual of every generation are selected. 2, an individual is selected based on its fitness relative to the other individuals. The better the fitness, the more like this individual gets choose. The possibility for the individual with fitness as to get choose the levels. Then after we start the solution functions. In the genetic algorithm, among an individual is equal to P equal to S upon sigma I equal to 1 to n Si. This is called the rutile wheel selection scheme. Third, two individuals are selected using 2. The one with better fitness is finally chosen. Individuals are chosen randomly. Each individual has the same chance of being chosen independent of its fitness. Next, individuals are chosen based on a two-stage stochastic selection. In the first stage, a temporary population is computed in which an individual from the base population may occur several times corresponding to the integer part of its expected fitness. Absolute fitness divided by the average fitness. The fraction of the expected fitness is used to give the individual another chance for being represented in the temporary population. This is best illustrated in the example. If the expected fitness is then this individual will be represented at the two time. In the temporary population, it 40% gets a 40% chance of being the represented a third time. In the second stage, one individual is chosen uniformly from the temporary populations. Then after we showing one point crossover operations, program, parent and two childs. Then 2 point crossover, parents and child 1 and child 2, two parents child 1 and child 2 crossover. Then after parents child 1 child 2 array uniform crossover operations. In these, after the individual virtues for the mating, once of the crossover is despite in figure take place. Finally, mutation is performed on newly introduced offspring. Right after the crossover, it introduces new genetic material into a population by replacing one parameter in a genome by a random value within the allowed range. The parameter p mut of the genetic algorithm thereby control the mutation probability. The parameters p cross and p mut have a big impact on the performance of the genetic algorithm, although a direct relationship to a gradient based optimizer can not be drawn. The crossover operation result in a local exploration of the target function, since only a combination of other individual is created. The parameter value are used. The mutation operation on the other hand introduce totally new parameter value into the genome which have never been used before. Therefore, the algorithm effectively escape any local extrema. There is no general rule on how to set those parameters. In the example of present, in some combination of those values have been tried. Then next one is the crossover in genetic algorithm. How to cross genetic algorithms? Crossover is a genetic operation used to vary the programming of a chromosome or chromosome from one generation to the next. Crossover is sexual reproduction. Two strings are picked from the matching pole at the random to crossover in the order to produce the superior offspring. The method chosen depends on the encoding methods. Different type of crossovers. One is single point crossovers. Then the crossover point on the parent organism string is the selected. All data beyond that the point in the organism string is swapped between the two parent organism string are characterized by the positional biases. Number one is the parent, another one is the children. Then crossover points. This is the crossover point, parent or children. Then crossover the points. Then create the different type of crossovers. Single point crossover in genetic algorithms. Then after we will decide single point crossover. Crossover 1, then 11011 crossover point, then 00100110110 chromosome 2 and offspring 1 offspring 2, then showing the single point crossover. Then after 2 point crossover, this is a specific case of n point crossover technique. Two random points are chosen on the individual chromosome string and the genetic material is exchanged at this point. Number one is parent, number two is children. Then crossover points showing in this notes. Then finally, this is the 2-point crossover, and another one is uniform crossover. Uniform crossover, each gene bit is selected randomly from one of the corresponding genes of the parent chromosome. Use the tossing of the coin as an example of techniques. Parent 1 and children 1. Parent 1 and children 1. Then the showing of the characteristics of the parent or children's. Then finally we can show the uniform crossover. Uniform crossover means कि equally distribution genes in the chromosomes. The crossover between two good solutions may not always yield a better or as good a solution. Since parents are good, the probability of the children being good is high. If offspring is not good, poor solution, it will be removed in the next iteration during the selections. And problem with the crossover, depending on the coding, simple crossovers can have high chance to produce illegal offspring. TSP with simple binary or path coding, most offspring will be illegals. Will be illegally. Then finally we can show, because not all the sites will be in the offspring and some cities will be there more than once. Uniform crossover can often be modified to avoid these problems. Example, TSP with the simple path coding, where the mask is 1, copy site from the parents. Where the mask is 0, choose the remaining site in the order of the other parents. सो दोस्तों ये था आपका जेनेटिक एल्गोरिथम, 1 सिंगल क्रॉसओवर, 2 क्रॉसओवर। नेक्स्ट हम पढ़ेंगे जेनेटिक एल्गोरिथम म्यूटेशंस के बारे में। तब तक आप लोग मेरे साथ बने रहिए, सेफ रहिए, सुरक्षित रहिए और मेरे यूट्यूब चैनल को सब्सक्राइब जरूर कीजिएगा। नमस्कार।